In this video, we will learn about microcontroller 8051. So, let's get started. I've asked my students to refer NPTEL video by Professor Shantanu, IIT Kharagpur. But before discussing what was in his video, let us first know the pioneers in the manufacturing of 8051 microcontroller. We have Edmund, Intel, Philips, Siemens. Besides these companies, we also have Texas Instruments, Hitachi, Toshiba, Motorola, Microchip, etc. Now I have a reflection spot for you. This is where I'll be giving you questions and you will be finding out answers to them. My first question is, can you list few applications where microcontrollers are used? I'll give you some time to find out the answers. I hope you have written down few applications where microcontrollers are used in your journal. Let's see what Professor Shantanu has to say about the basic block diagram of 8051.
Components that you have in the microcontroller, it has got 4 kilobytes of ROM, then 128 bytes of RAM, 4 8-bit IO ports, 16-bit timers or counter, and 1 serial. So this is the chip that we have. There are various manufacturers. 128 bytes of RAM, 4 IO ports, 1 serial port. There are 2 timers, timer 1 and timer 2. And we have got this fast control. The fast control will be controlling the operation. There is the processing unit which is doing the processing. So when we are discussing about the microprocessors, actually we discussed about this CPU only. As you can see, that is the ROM, RAM, timers, the IO ports, serial computer. Serial computer was also main part of it. But most of the components are outside. But in case of microcontroller, all of them are together. So in the we have got this CPU, then the interrupt control, and the oscillator that will be generating the clock that will be coming from that will be controlled.
Now, Professor Shantanu has listed out few features of 8051 microcontroller. That is, it has on-chip oscillator, it has 6 interrupt sources, it has 64 kilobytes of program memory, 64 kilobytes of data memory, and code memory is selectable by external access. You may have external memory as data and as code. So we'll see few more features of 8051 series. So 8051 has a 8-bit CPU. Most of the microcontrollers in 8051 family have a 256 bytes of on-chip RAM which acts as the data memory. But in case of 8051, what we have is 128 bytes of RAM. This internal RAM is further organized and structured, which will be seen in some time. So, 8051 family comes with 4 kilobyte, 8 kilobyte, 16 kilobyte and 32 kilobyte of ROM, EEPROM or OTPROM. In 8051, what we have is 4 kilobyte of ROM. In some cases, we also have ROM-less microcontroller. So, in that case, we may have an external program memory. We have 32 input-output lines which are formed with the help of 4 8-bit ports, which can be used for input and output operations. We have a multi-mode full duplex serial port which contains UART, and there are a number of interrupt sources which differs from version to version in 8051. The important interrupt sources are one from the serial port when a transmission or reception is complete, two from the timers, and the other two from the input pins INT0 and INT1. It has 64 kilobyte of external data memory space and 64 kilobyte of external memory space for program. It also has power saving modes. Now coming to a more elaborate block diagram of 8051. But before that, let's see the internal structure of RAM. This is the internal structure of RAM, where we have 4 register banks. So each register bank has registers from R0 to R7. Register bank 0 starts from 00H to 07H. Likewise, we have other 3 register banks. These can be selected with the help of program status word. Program status word is nothing but the flag register, which is similar to that of 8085. Then we have 16-bit addressable registers from 20H to 2FH. We have general purpose registers from 30H to 7FH. We have some space for special function registers. Special function registers as data pointer, TCON, TCON, T-mode, timer 0, timer 1, serial control registers, serial data buffer registers, interrupt enable registers, interrupt priority registers, program status word, which is similar to the flag register of 8085. We have accumulator, register B, and some additional memory for stack operation. So this is the program status word of 8085, where we have 2 bits, that is bit 3 and bit 4, which determine which register bank is selected. For example, if RS0 and RS1 are both zeros, then it means register bank 0 is selected. So on the basis of logic of RS0 and RS1, we can know that which of the register banks is presently selected. Now I have a reflection spot for you. Now that you have studied the block diagram of microcontroller, you will be able to list out in which ways microcontroller is different from microprocessor. I'll give you some time to list out the differences between microcontroller and microprocessors. Now coming to the more elaborate diagram of block diagram. Now coming to the more elaborate block diagram of 8051. So first we have arithmetic and logic unit. We have accumulator, which is 8-bit register. We have register B, which is for performing multiplication and division operation. We have program status word. As I said, it is similar to the flag register of 8085. We have 16-bit program counter. We have data pointer, which is a 16-bit register. It has a higher byte and a low byte. So this can be used as a 16-bit register or as 2 independent 8-bit registers. Then we have special function registers, RAM. So these consist of interrupt enable registers, interrupt priority registers, program control registers, serial data buffer register, serial control registers, timer control registers, timer mode registers, timer 0, timer 1. Then we have register bank within your internal RAM. We have interrupt control and timing and control unit. So this unit is responsible for the interrupt controlling and for the synchronized operation within the 8051, and also the synchronized operation between 8051 and external peripheral devices. We have ports, port 0, port 1, port 2 and port 3 for informing. So we have port 0, port 1, port 2 and port 3 for input output lines. As you see, port 0 has address lines from A0 to A7 and data lines from D0 to D7. These are multiplex address data lines. Port 1 is used as simple input output lines. Port 2 has higher byte of address lines, that is from A8 to A50. Port 3 is bit special. It has its interrupt pins, counter and timer pins, serial data, that is reading and writing data in serial form. This is the pin diagram of 8051. So from pin 1 to 8 we have port 1. From pins 10 to 17 we have port 3. From pins 32 to 39 we have port 0. From pins 21 to 28 we have port 2. So pin number 9, RST, it is resetting pin for the device. We have pin 19, which is XTAL1. It is input to the inverting amplifier, which is part of the on-chip oscillator circuit. When clock, that is external clock, is used, it is connected to the external oscillator segment. We have XTAL2. It is the output of inverting. It is the output of inverting amplifier, which is part of the on-chip oscillator. When the external clock is used, it is left unconnected. We have ground. It is the circuit ground. All the voltages are specified with respect to it. We have VCC. It is for the power supply. That is pin number 40. We have PSEN bar. It is program store enable. It is output control signal. It is a read stop to external program memory. Then we have ALE at pin 30. It is address latch enable output for latching low byte of address during access to external memory. EA bar at pin 31. It is external access. It controls the access of memory, that is program memory. So RXT is serial input port. TXT is also part of serial output port. INT0 is external interrupt. INT1 is external interrupt. T0 is timer 0 external input. T1 is timer 1 external input. WR bar stands for external data memory write stroke. RD bar stands for external data memory read stroke. So I believe you must have understood what was explained in this video. Thank you.